Okay, so hello and welcome back to another geology video. Today we have two rocks to compare. So we are looking at the top, and a lot of people, when they actually see these, they think, oh yeah, these are both granites. And I've had engineers say that to me as well. I haven't met any geologists on site, so basically no one else has actually made any confirmation, but I'm pretty sure in my analysis. I could be wrong though. So anyway, we are looking at the actual rock. I use this siltstone as a pointer, which is a quite soft rock. So what we can see here is it looks like we have potassium feldspar, we have the great quartz, we have some, it's probably a mica, and probably also we might have hornblende or amphibole. See, I got this out in the field, but this was just rubbish. Both of these were rubbish. So I don't know the actual formation, where it come from. In my state of Victoria, we have a lot of granites, which is this rock here. So granodiorite. So this is mainly just got feldspars. So calcium and sodium feldspars. It has some, looks like biotite, hornblende, amphibole should I say, more likely amphibole. So it's a bit hard to actually tell the difference between amphibole and hornblende in these materials. You need to actually use the graph. So it looks like we also got muscovite micas. It looks like there's more biotite muscovite micas in this type of material. They can occur together. And we also have the grey quartz. And I don't see any potassium feldspar in this specimen here. So I'm going to say this is more like a granodiorite because of the higher percentage of darker coloured minerals and the absence of potassium feldspars. So this would be an equigranular because all the minerals look pretty much the same size. So that means there is no phenocryst in it in this material. If you keep rotating it, you see that there, okay, there's the extinction where the light on that crystal peters out. So that's called extinction. And you just turn it around and all the crystals are the same size. Doesn't matter what way you rotate the actual material. Okay, so if you look at this rock here, you can see, looking from the top, it looks like it has large massive crystals. So this, a lot of people will probably say, is a monzogranite. So it's a large crystal rock. So it would have actually cooled quite slowly, or if it had water, probably fairly fast, but the crystals form fairly quickly. But if you turn it to the side, this is where it gets interesting. The actual material is flattened. So this indicates that this had pressure on it going this way. So it's more likely is that this is a metamorphic rock. And I would just say it's a granitic gneiss. So we do have a lot of potassium feldspars. You also have a lot of the other feldspars. You have quartz. If this is probably amphibole, and because it's a metamorphic rock, it's probably a mica as well. So, but I'm not getting any of the platy structure in this darker colour material. But there will be amphiboles in this material. So I don't know the mechanism that actually formed this, whether this was actually a granite in the first place. whether it was another sedimentary rock like a mudstone, or maybe a sandy mudstone had a lot of clays and a lot of silica, so just a lot of sand. And when the actual pressures cause this material to partially melt and it's differentiated into its formations to form this large crystal structure that we see in this granitic gneiss. So that's basically how you'd tell these two structures. So you've got a granite, so this is formed underground batholith. Then you've got this granitic gneiss, which is formed also underground, but has a lot more pressure and obviously a higher temperature that has affected the parent material. Even though the temperature of this rock's probably higher, this was a melt, and this one was most likely not a melt. It's just partially melted, differentiated, and separated into the actual formation. Anyway, hope this helps you with your collecting of material, and have an awesome time learning about geology. Thank you and good night.